Good afternoon. At first I was worried. I thought, like, they've given me the last talk of the conference, well, the day, in the smallest room. But then there was a smaller room, so I feel a little bit better about myself now. So thank you for coming here and not in the smaller room. So anyway, I'm going to give you a talk on Ktor. How many of you know Ktor? How many of you used it? Okay, you're not going to learn anything new. I don't even have new jokes, I'm sorry. About the only new thing that I can tell you in this talk, if you've seen this talk, anyone seen this talk before? Okay, so I updated to the latest version of Ktor and nothing broke. That's the new thing. Okay, so you can go to a small room now. But thank you for coming. So yeah, I'm going to give you a talk about asynchronous frameworks for connected systems. Okay? Now this doesn't attract a lot of attention, so normally what I say for distributed microservices back with blockchain. Because it doesn't matter what technology it is, as long as you throw in microservices and blockchain, it's going to be awesome, and you're going to be able to sell it to your manager, and everything's great. So the good thing about this is that you can actually create microservices with Ktor. Now the big question is, what is a microservice? But it doesn't matter. It's whatever you want it to be. So what is Ktor? Ktor is a server. It is also a client. It is multi-platform. It is Kotlin through and through. How many of you here are familiar with Kotlin? Okay, that's a good start. So Kotlin is a programming language. And it is asynchronous. Ktor is also open source, which means, in our world, free. It's built and maintained primarily by us, JetBrains, the ones that also make Kotlin, not that other company that sells phones. Inspired by other frameworks such as Wasabi and Kara. Now, how many of you have heard of Wasabi? Not the source, the framework. Yeah. So Wasabi is something I created. Nobody ever used it. It died, but it inspired other people to create this. And Kara? Kara was kind of like someone that liked Ruby on Rails, saw Kotlin, and decided to bring Ruby on Rails to Kotlin, and they created Kara. And then someone thought that Kara is too overly complex, so I created Wasabi, and then Wasabi led to Ktor, and now there's a new project on GitHub, which is Kara, or Ruby on Rails, on top of Ktor. So we're full circle back where we were. We could have just saved ourselves 5 years. Ktor can be used for creating server-side applications. That means HTTP APIs, which is different to RESTful systems, but you can also create RESTful systems, because RESTful systems are basically systems that comply with a series of constraints. They're not pretty JSON with HTTP endpoints. For socket programming, for client-side connections, and this is probably the most important slide. Ktor's goals are to be simple. They're meant to be flexible, performant, cross-platform. And I always kind of get amused that I actually came up with this creative slide, because who would put on a slide that, Ktor's goals are to be very bad in performance, very rigid, and just horrible, right? But I had to fill in something. So let me show you a simple server. This is basically the simplest of the servers. Now, if you're familiar with JavaScript, anyone? It's okay, you can put up your hands. I'm going to judge you. So anyone use Express.js? Right, so this is why I created Wasabi and now Ktor and all of this. Express.js was a step away from ASP.NET MVC, which was, or Ruby on Rails or anything. It was basically just simple endpoints, trying to be as simple as possible. And this is where it's all kind of inspired. So here you can see that essentially in my main function in Kotlin, what I'm doing is creating an embedded server, and we'll talk about the different ways that you can create servers, but in this case, I'm just creating an embedded server running on Netty. And then inside that, I'm creating what's called the routing, or the routing, depending on where you're from. And inside that routing, I am now creating a GET call, and that is responding with respond text. Now, there's a bug here. Can anybody tell me what it is? Except you, because you went to the previous. Nobody? Exactly. So that's just to know if you're paying attention. Yeah, this is text.plain, but with today's browsers, it doesn't matter. You can send back whatever you want, and they'll accept it. So what is a Ktor application? A Ktor application is basically a series of modules, and you can think of module as anything you essentially want. It's kind of like this idea that was created in Ktor that nobody really uses. To a certain extent, some people use, but think of module as like a grouping of your different aspects of your application. So, you know, for example, in Spring, how many of you do Spring or know about Spring? So Spring has the concept of customer controller, right? Module has got nothing to do with that, just so that you don't put that pairing together. Module can be, for example, something around your customers, invoices, and I don't know, payments, and then you can have another module that's, for example, for registration. How you group it and mix and match things is completely up to you. And we'll see a little bit about how to actually use modules when we see the code. But inside a module is essentially where your application is. So you essentially have this request that comes in, it goes through this routing mechanism, and then you have your app logic, and then your response. As simple as that. In between these things, what we have are features. And these features are essentially things that get added to your application. Now, if you're familiar with Express.js or any of the other technology, you may know this as other terminology such as interceptors or middleware. Right? In Ktor, they're essentially called features. And routing itself is actually a feature as well. So this could be, for instance, encoding, compression, all of these things that get added to the pipeline in different phases from the request to the response that add functionality. And as I said, routing is also a feature, but the majority of applications already have routing built in, so to speak. So let's see some code. Okay. So we'll start with something very simple. So I've got my example that we saw in the slides up here, where I have routing get, and this is actually correct. It's returning text.plain. Now, the only thing that you'll notice here is that I don't have any embedded server netty. What I showed you in the slide, I don't have here. Why? Because generally, you don't create your applications in this way. What you do, you try and externalize certain aspects of your application to configuration files, which is kind of a better way to do things, right? Because it's also flexible in that sense. So in this case, what I'm doing is I'm defining the routing. However, how this application runs, on what engine it runs, all of that, I'm delegating to configuration files. And that configuration file is over here. It's called Hocon, syntax that it follows. And essentially what it is, I'm saying that this is a Ktor application. It's going to be deployed on port 8080 or the next port you find free. And then the module, it's going to consist of this module. All right? So that's the simple is this thing over here. It matches in names. Now, I could add multiple modules here. I could separate them by comma and add multiple. And that's what I was talking to you about a module. You can have one module or you can have a million modules. In this example, what I'm doing is basically using this configuration file to go through the example. So in this case, what I'm doing is essentially just loading the simple module. Now, if we go to another file over here, which is called the application, this is the one that actually loads those parameters. So in this case, my main entry point is Ktor server.netty engine main, and then the arguments. And the arguments are what's being passed on the command line, and if nothing's been passed on the command line, then it's going to default to the application conf file. Okay? So what do I run? I basically run this app. And what this is going to do is going to read the app configuration file and launch the application for me. Okay? There you go. So you get the hello world, right? Well, you see it there. See that? Hello world. Now, notice that was pretty fast. Someone said to me, how do you make it so fast in the demos? I'm like, I don't. It's just, that's how it is. Ktor is quite fast to launch. Now, you can also, to get started with Ktor, there's multiple ways. You can go to, if we open up the browser, and if we go to start.ktor.io, I don't know where this was inspired from, but you can, yes, Ktor with project, building on the shoulders of giants. So you can see that you have all of these server and all of the features that we spoke about. And if you're not a person that likes to open up their browser, then what you can do is also inside IntelliJ, just go File, New, Project, and then Ktor also gets you started, right? So when you click all of these things over here, it's going to add a bunch of lines to that code that gets generated, but we're going to do that manually to see how it is. Okay? So let's go to the next one. And what we're going to see is how to serve static pages, right? So I'm not going to run every single demo here because you're going to get bored. But notice that the only thing that I've done now is essentially just change a value in the configuration file, and I've restarted the same file. But in this case, what I'm doing is using the static example. And the static example, what it is essentially showing you that Ktor has built-in support for static files. So if you want to serve static files, all you have to do is inside the routing, call static, and then the path, which means that anything off this path is going to be served as static, and then map that to the resources, which would be essentially a folder on your machine that serves all of the static content. So you can see here that I have static, and then inside this I have Ktor logo SVG. So in the browser, I could do localhost 8080 and then static Ktor logo.svg, and that should give me the Ktor logo. Okay? And you can define multiple static entries. Like, it doesn't all have to be under a specific URL. Anything that you put will just be mapped to that, and you can have these in different folders, etc. Now, HTML. This is an interesting one. How many of you have seen code like this? So what is that? It's a DSL. Yeah, what else is it? It's HTML, right? So that is essentially HTML. This is the HTML_X library from Kotlin. Anyone familiar with it? So Kotlin X has, there's Kotlin, and then there's Kotlin X, which is a whole bunch of other functionality that we provide. And there's this library called HTML_X, which essentially is statically typed HTML that you can use in your application. Now here what I'm doing is essentially doing respond HTML, and I've got this beautiful HTML here, which gives me all of the completion. I get all of the functionality that you would expect in the IDE and be able to write HTML. And the best part of it is that I can mix and match that with actual Kotlin code, right? Back in the old days, in the very, very old days, we used to call this server-side rendering. Remember that? Yeah? And then single-page applications came about, and everyone decided to do what everyone else does, and now everyone's deciding to go back to server-side rendering, but that's the beauty of our industry, right? Some people look at this and they're like, oh, this is disgusting, this is horrible. Like, you're mixing HTML with code, that's just horrible. Yes, many people do the same, they call it React, right? Except there it's called JSX, here we call it Kotlin. But essentially, it's the same thing. And to be fair, it's not that you're mixing and matching. Like, the idea behind separation of concerns is not that you should keep technology separate, but it's that you should keep concerns separate. And this is actually about viewing information. So this essentially, I'm not going to run this, but this basically what it's going to do is when I call HTML DSL, is going to shoot me back some HTML DSL, right? And if you're into the CSS stuff, we also have CSS, so you can do static typing using CSS, or you can just combine it with your dynamic style sheets and basically just return HTML at any time on the server side. You don't need any kind of view engine. Now, if you saw in the browser when I was showing you the different entries, you can see that you've got FreeMaker, you've got Velocity, Mustache, Thymeleaf. So if you want to use some kind of view engine, we have support for that as well. But if you just want to do your own server-side rendering and just HTML with Kotlin, that is as simple as it gets. Okay, now so far what we've seen is how to actually do like a get verb, right? But HTML consists of mode. And here, this is how you can actually do a post. So in this case, what I'm doing is I've got my routing, and then I've got get, which essentially is going to give me back a form. So I'm using respond HTML to create the form. I'm adding a paragraph. I'm adding a form. Notice that I have the actual name of the form. The action here is form, and keep an eye on this because I'll show you a better way to do this later on. Multi-part form data, which means what? That Ktor supports out-of-the-box file uploads and input fields, method post, and then just the layout of the form. Then I have another entry, which is post, which is the exact action that's on the form. And then what I'm doing here is I'm going through the request, and I'm analyzing whether it's multi-part, which means it's a file, and then basically on that, on each of these parts, I'm processing each of these entries. So all of that is being done for you, right? You don't have to do any kind of encoding or decoding. One thing you want to notice is that a lot of the things in Ktor are on the call object. They're not on request response directly. And this is kind of like, you know, when you're working with sockets, you have this call. You don't necessarily have the request response kind of approach to things. So this one, if I want to launch it, I basically do the root, so I can come here and then get rid of this and request it. And you see that I have my form, and then I can say choose file. And let's, for example, say this one, open it, and send. And you see that I get my form field, and I get the actual content type of the application. Okay? So you have support for multi-form data in Ktor. Now, all of these things that I've been showing you are actually what I was saying. Some of them are implemented as features. So let's look at some other features that we have. So here's a very, very simple feature, which is called default headers. And essentially what it does is just give you back a timestamp and some other information that the header that by default it actually doesn't provide if you make a request to Ktor. And all I have to do to use a feature is just install it, right? So what I'm doing is installing the feature, and then I'm defining my routing mechanism. Okay? Nothing else. Now a feature consists of two parts. One is the initialization, which we'll see, and the other one is the actual work that it does. In this case, all I have to do in the initialization is just say install. And then if you just type install here, you know, you get a whole bunch of different features, like, for example, the content negotiation. These are all different features that are available out of the box, and then, of course, you can extend it with your own features, which we'll see how. And one thing that, if you remember, I mentioned to you at the beginning that routing itself is also a feature. So where am I doing install routing? I'm actually not doing that. Why am I not doing that? Because of this function over here. Now, in case I didn't mention this, I'm assuming everyone's familiar with Kotlin. This is a lambda, right? This is a higher order function. So if you look at this routing, you can see that this is actually installing routing, right? So the routing is the one that's doing the install routing. And it's just a convenient function that allows us to then define all of the routes inside that block. And we'll see that generally you don't want to do this either, because your application is going to grow tremendously if you have everything in one segment, right? Next thing you know, you look like you're programming JavaScript. So here, default header is just going to return some headers, okay? So we won't run this. Let's go to something a little bit more interesting, which is JSON. So in the case of JSON, what I want to do is basically provide support for JSON out of the box, right? So that when I send back some data, it can automatically serialize it into JSON. Now here there's the feature that I have to install is called content negotiation. Personally, I don't very much agree with the wording here, but that's another debate, because content negotiation is more than just serializing data in a specific format, right? Who of you are familiar here with content negotiation? Right. So content negotiation is essentially when you make a request to your browser, right? You can see that if we go to network, and you can see that here I have content type image PNG, right? And normally, although I'm not showing it here, let's go to google.com. Let's see. Okay, let's see, for example, google.com. Okay. So, does anyone see the accept? I am missing it. There. Yeah. So you see this over here. This accept header, okay? This is essentially saying when I make a request, these are the content types that I support, right? But it's normally not just a single content type. It's multiple content types, and each of them have this parameter Q. And if they don't have the Q, the default value is 1.0, right? And this is indicating what's called the weight or the priority of which one I support. So this browser is sending a request saying I accept text HTML, application HTML, application/XML, all of these different formats. This goes to the server, and the server then breaks this apart, orders it by weight, and says, okay, so this is what the request accepts. This is everything that I can send back. Let's start sending that back, and if it accepts it, great. If not, we'll fall back to the next level, right? That is the whole concept of content negotiation. So here, when you install content negotiation, it's now going to take care of that for you. It's going to analyze the types of accept headers that come in, and then it's going to send back the content type. Now, in addition to that, what this is also doing, and this is where I say that I'm not entirely agreeing with the terminology, because it's also, this is the feature that you have to install to then get serialization into specific formats, right? So if I want to support JSON, what I can do is define the serializer that I want to use here. Now, out of the box, we support JSON, Jackson, Kotlin serialization, and in the case of JSON, notice that I'm saying I want to use JSON, but this also has its block. And what is that block? That is the initialization block that I was talking about before when you install a feature. So a feature comes with just the install, but optionally it can also add certain parameters to say this is how I would like you to configure this specific feature. So in this case, this is nothing more than all of the different hard-coded configuration options that JSON, the serializer, provides. So we've encoded all of this for you. You get the completion. You get all of the options that JSON provides. Okay? So in this case, I'm saying I want to configure JSON to have pretty printing, to serialize nulls, etc. And then essentially, as soon as I've got that installed, when I do a get customer, that's basically going to just serialize this back for me in JSON. I don't have to do anything else. And I keep saying JSON when I meant to say JSON, and I say JSON when I meant to say JSON. Apologies for that. But it's kind of like GIF and GIF, right? It doesn't matter. So let's do customer, and we can see that we get back JSON, right? So obviously here, I'm doing it for JSON. This will work for XML. It'll work for whatever kind of encoding format that you have. Authentication. Out-of-the-box authentication is also supported. I won't run it, but we have support for OAuth 2, and we've got support for the simplest of things like basic authentication. How does it work? Exactly like we saw before. So in this case, I'm doing an install authentication, and then I have a basic auth. So now I'm saying that as part of authentication, I'm going to support basic authentication. In basic authentication, you have this concept of realm, which is basically the area that is authenticated. And then you have some very, very complex logic to validate the credentials. Don't ship this in production code, please. And then all I do, so I've initialized the authentication mechanism of how I want things authenticated. And then when I want to use that, I just do authenticate and wrap everything that I want authenticated in a block authenticate. Okay? Now, the important thing here is that I could have 10 basic authentications if I want. So I could have basic, another, right? And then if I want to use the another one, I would use another over here. If I want to use OAuth 2, I would use OAuth 2 authentication and put it in the workflow. So in this case, let's just run this one. In this case, you can see that this route over here doesn't actually require authentication, and anything under secure does. So if I were to launch that, you see you need credentials to access secure. If I type secure, I get my basic authentication. And then I get access to the secure area. Now, as I said, like generally nobody really nowadays uses basic authentication, but it shows you how to actually configure it. With OAuth 2, it would be essentially the same. Now, the features that we've seen, how do you actually create a custom feature? It's very, very simple. You essentially have to you follow a certain rule, right? You create a class. That class has to have this nested class that contains the actual initialization parameters for that function, sorry, for that feature. So in this case, I have a class configuration, and it has two parameters, name and value. And then, basically, this is the call to intercept. So this is essentially how I set up the actual feature, and then this is where the work's going to be done. And the work that's going to be done is essentially you have to implement an application feature class, which you do as a companion object, and inside here is where you actually do the actual work of intercepting that feature, intercepting the call and then processing and doing what you want. And from there, you have access to all of the configuration parameters. So this is basically the code to implement a feature. And then when I want to use it, just as before, I do install custom header. In this case, what are my parameters? The ones that I put in the object, in the nested class, so you see that I get completion for those. These are the ones that I have access to, and then I just use it exactly as before. Nothing different. And if you look at all of the different features that are in Ktor, essentially all of them are implemented in the exact same way. Okay? Implement an application call, an initialization block where you set all the different configuration options, and then the actual intercept, which is where you're doing the heavy lifting. Now, routing apps. Ktor, as opposed to other frameworks such as, for instance, Spring Boot, is not very stringent in how you have to define things. So, for example, if you take a look at ASP.NET, MVC, or Spring Boot, or any of the other frameworks, they essentially tell you, you want to respond to the URL endpoint of /customer. Create a class called customer controller, right? You have to follow these patterns. In certain frameworks, you not only have to follow patterns, but you have to follow folders and structures and everything. Like if anyone's ever done MVC or Rails, back in, you had to put a folder controllers, a folder views, a folder models, and then place things there. With Kotlin, it's very versatile. You can do essentially anything you want, which is a good thing, but it can also be a bad thing, right? Because like, how do I structure my program? How should I be doing things? And we're going to see that. But so before that, though, don't take this as an example of, is this how my application is going to look like? Because this is horrible. Like, this is not the way you want to write applications in Ktor, or in any language, or in any framework, to be honest with you. But what this is showing you that the flexibility not only comes of how I structure my application, but how I can even define my roots. So here I have my get root, which is the root of the root, if that makes sense. And then I have customer. But notice that instead of using get/customer, in this case, what I'm doing is root customer, and then inside that, I'm doing get and post. So now I'm saying that anything that goes to /customer has a get and a post, and then they behave differently, right? So I'm defining the different ways. Also notice that I have query parameters ID. What is this ID? This is essentially the query parameters. So if I do ID 10, that is what that ID is referring to. It's a little bit yucky here because it's what? A string. And we'll see a better way to do this. In this case, I'm doing root employee and I'm doing get ID. What is this? This is the root parameter. So in this case, this would be customer 1. Right? This is as part of the root parameter, and I call it with call parameters ID. In this case, I have nested roots. So I have shipment, and then inside shipment, I have international. So in this case, this would be shipment, international, and then a get, and I could have my post here for that, or all of the different headers possible. Okay? But this is showing you like you can basically organize your roots any way you want. You can organize them by the equivalent of what would be a controller, and then just do get, post, head, option, put, delete, or you could have different paths. It's entirely up to you how you want to do it. The one thing you don't want to do, however, is this. Like, you don't want to end up in a situation where you have everything in a single file or a single function. So how do you actually structure your application? So one thing that you can start to do is, instead of having routing and then inside that have get, is basically move that function out. You can just move it to its own function because ultimately, essentially, it's a function call. But a better way than just making it a function call, a good way is to do it as an extension function to root. Because when you do it as an extension function to root, then you get access to the get, post, delete, all of these verbs. Right? So it's just much easier. You don't have to do rooting and then inside that write all of the different verbs and all of the different paths. So one way to structure your application is, for example, to have a file where you have root home, root about, root employees, etc. Or you could divide it up into multiple files. But using the extension on root is a pretty decent way to try and structure things, right? And then inside my actual application, so what we saw before here, instead of having all of this, instead what I'm just doing is rooting and then calling all of these different functions. And then this is basically injecting that root in. But again, it's very flexible. If you want, you can also kind of create a class and then do an initialization of the root in that class. It really is up to you how you want to define your application structure. Now, a few things that we've seen, if we go back to this post, if you remember I talked about this string over here. If we go back to the routing, we talked about the query parameters ID, over here the root parameters. How can we try and improve this in a way that we try and move away from strings? Because we all know what happens, right? You want to refactor something and then it's in a string and it all goes to hell. Now, if you're using, of course, if you're using IntelliJ IDEA, what you can do is refactor, and then IntelliJ IDEA says, oh, do you want me to refactor all of these strings that I found? And you quickly place, yes, do refactor, and then you're like, oh shit, what did I just do? Let me revert it back, because IntelliJ likes to, sometimes go way and beyond. It goes the extra mile. So what you can use instead is location. Now, this is, again, somewhere where I disagree with terminology because location isn't a good thing for this. How many of you are familiar with the header location in HTTP? So a header is really, really useful. Have you ever created a record in the database and it's generated an ID and you want to send that ID back? You send it back as part of the JSON payload? Normally, right? Do you know that there's an actual field specifically for that in the HTTP specification, which is called location? So when you do a post, which is to create a new resource, there's a header in the specification that says location will give you back the URL of the newly created resource. So when I do customer/new post, I should respond with customer/the ID. You don't need to send that back as part of the JSON payload. Now, if you're sending a whole bunch of other stuff back, sure, add the ID. But ideally, it would be better to use the location. That is what the location header means. The Ktor team has decided to use the same terminology for this, which is a little bit confusing. But basically, this should be renamed hard-coded, strongly typed route. And what this is basically using is just playing on the concept of essentially using a class to allow you for strong typing of your root definitions. So notice that the convention is to use the class in lowercase because it's not really a class. It's just something that we're using. This is, again, borderline. Are we starting to become JavaScript? Oh, if a function is in uppercase, then it means it's a constructor. If it's in lowercase, it means it's just a function. So if something in Kotlin, if a class in Kotlin is in lowercase, it means it's not a class. There you go. I just coined that term definition. So it's using index, and then here I have class employee, and basically what it's doing is mapping this employee ID. So it's saying this is the URL for that I'm defining, and then what I'm doing is doing class employee val ID string. So now instead of doing get, as we saw before, kind of get with the string, what I'm doing is using the generic type of get, which is get index, and I'm passing in the class. In this case, I'm doing get employee, and I'm passing an employee. So this is going to do a get on employee with a root parameter. And how do I access that root parameter? Well, now that this is of type employee class, well, not class, that thing that's not a class, I can just do .id and get access to the root parameter. Okay? Now this is good because then what I can also do is not have these form and action names inside the HTML that I spit out or whatever. Everything is now strongly typed. Location is still experimental. I think it's still experimental because they still haven't figured out a good thing to call it. So if you want to use it, you have to use this use experimental flag in Kotlin so that it doesn't complain to you. Right. When it comes to async, so Ktor is basically built from the ground up using coroutines. So essentially that means that you don't have to worry about anything. It's all going to work and it's all wonderful and the world is sunny, and although it's a little bit too sunny sometimes. But what happens if you want to kind of like have a long running process, right? Something that you don't want essentially to block. Now, initially the way that Ktor was implemented, there's like this fail-safe mechanism in place that if it detects that your request is long running, it will prevent the server from blocking and it will try and offload it to another coroutine. However, the general recommendation is that you do what you do when you're using UIs in Android or whatever, which is long-running processes basically just launch in its own coroutine and then come back with it and use it the same way that you would whether you're doing Android programming or anything else, or desktop programming. But under the covers, this is all asynchronous, it's all suspendable functions, it's all basically coroutines. And last but not least, I know that for some folks this is not really important. I mean, I remember testing back in the old days when I used to write code, literally we used to just test it by shipping it to the customer. How do you test? So Ktor is basically built in a way that you do not need to create everything, have it up and running in order to test. You can test your whole entire pipeline, or every feature that it has, without having to run the server. Now that doesn't mean that you shouldn't run the server and test. That's usually an integration test. But what it does mean is that when I want to run some tests, it's going to be pretty fast, right? I don't have to get everything running. So if I go to my test over here, application test, see that I can basically just say run application test, and it's essentially run it, and it's already done, right? And the only thing that I needed to do was use this with test application, and then pass in my application with the parameter testing equals true. So this application is this testing, and by default, it's got the application testing false. That'll be funny if you put that in true in production. And that's it. So you can basically test the whole entire thing without having to start up the engine. But again, as I said, you should usually do your integration tests as well. Yeah. Okay, so let's just give you a bit of a roadmap of where we're going with Ktor, etc. Deployment options. Embedded. You have Jetty, Tomcat, Netty, CIO. Anyone knows what CIO is? Okay. IO. Yeah, you know what the star is? Not production ready? Yeah, definitely not production ready. So generally you don't want to use that because it's not production ready. Like this isn't even experimental. This is just not production ready. Someone asked me, why are we doing that? Because we want Ktor to be multi-platform. So Netty is an amazing engine. Netty is fantastic, but at the same time, we want to be able to run this on any platform, so that's why we're trying to do the lower level stuff with that as well. Containers, you have Tomcat Jetty, supports Java 6 through to, I never update this slide, I think it's Java 17 now. Are we on 17 or what? I can't remember. GAE, Heroku, Docker containers, Kubernetes, Q8s, Q9s, I don't know, I'm not keeping up to date. And to also, yes, to get started, go to start.ktor.io, or ktor.io as well. If you come to the browser and do Ktor, got an awesome website. You know how this is like used for breadcrumbs? Yeah, we did it wrong. But it's got some nice samples there, and you've got essentially everything that I've shown you is there. To give you some more insight, we've also released 1.3.6, I believe, right now, just recently, last week. 1.3.6, I think. And Ktor is not going away because we're using it ourselves, right? Which is sometimes people ask, like, what is this? I mean, is this an official JetBrains product? Yes, it's an official JetBrains product. And if you have heard of JetBrains.com Space, anyone heard of Space? Right? Space is our new integrated team environment. So it's like code repository, chats, blogs, issue tracker, automation, everything. And that's built on Ktor. Right? And we've been 3 years building that, and we're going to continue to support it. So Ktor is here to stay. It's officially supported project by us, JetBrains. Ta-da. Okay, we are done. Any questions?
We have 8 minutes of questions. Wait.
Do you have integration with JUnit? Yes. I mean, in what sense? I mean, the test I was using JUnit.
In my application, I have now JUnit. So imagine I wanna move it to Ktor from Spring Boot. So I didn't wanna recognize all my tests. I just wanna have magic.
Yes, I think your biggest problem there isn't going to be support for JUnit, but that those tests that you've written for Spring Boot, I mean, I don't know how you've written or how tightly integrated they are with Spring Boot, whether they will serve for Ktor. If you're just testing the business logic, but like JUnit is completely independent. JUnit is supported by Kotlin. So there's no real issue here. So yes, your answer is yes. Is it going to be easy? Depends on what your tests are.
Okay, more questions?
Maybe I missed it, but does Ktor support some kind of automatic form binding like Spring MVC does?
Automatic forwarding.
Form binding.
Fourth?
Binding the form data to an
Oh,
object.
okay, data binding. No, I don't believe that we support any kind of automatic data binding. So the one thing that we got to kind of like, it'll probably be important to, I know it's sometimes a blurry line, but Ktor is not trying to be Spring, right? You know, Spring is, Spring is not just an HTTP framework. It is an entire application framework that you can basically annotate something or end up annotating 70 things on one thing and have all of this different functionality. So we don't have, for example, data binding, right? As far as I know, the team is not planning to do it. However, does that mean that it's hard to do? Not really. I mean, you can do it as a feature, right? So essentially anything that you can think of can be done as a feature, right? And ultimately, that's what it's going to boil down to. What we would love to see is, of course, an ecosystem whereby we provide you support with certain things, and then tomorrow, where you do file new, in addition to seeing our features, you can see community contributed features, right? And then like data binding, and then bring that in, right? But it would be nice to kind of have these things, right? Because I mean, for a lot of people are against the whole concept of automatic data binding, right? But then for some simple applications, sometimes it just makes sense to have it.
Okay. What?
Well, I'm familiar with Spring Boot, so I'm doing some sort of comparison. What would be the preferred way to package and deploy such a Ktor application? I'm like in Spring Boot, you do the executable
Make jar,
jar,
not
for
war.
example.
I can say the same thing. Make jar, not war. Again, it depends. I mean, we deploy jars. It doesn't really, there's no real preferred way. We support basically multiple options. So really there isn't a preferred way beyond, like, for example, what Josh even talks about around the benefits of jars over WAR files, right? So it really could use, I mean, we deploy with jars.
Okay, more questions? There are lots of time. Yep, gentleman in blue.
Yeah, I was just wondering, is Graal VM supported?
Graal?
Yeah.
I don't know, I haven't tested it.
Okay.
I don't know. That's a good thing for you to test, and if it isn't, pull request. And also, just to highlight, you know, I've shown, yes, over here.
How long do you think it will be before Ktor will be supported in Kotlin native?
Yeah, that's where I was actually going to go. Hold on. Yeah. So, Ktor, first of all, before that, I've shown you Ktor on the server side. Okay? And I talked to you about how Ktor is multi-platform. Ktor only runs on the JVM right now, on the server. But Ktor is client and server. So the client actually is multi-platform. So the client runs on JavaScript, it runs on JVM, it runs on Kotlin native. Now the next question is how long before? We need to first finalize the CIO. Once we get the CIO, many of the other features are already basically working because of the Kotlin X multi-platform libraries that we have. So I think that that's basically right now the showstopper. That and time, essentially. And I did mention that it's open source, right? You know, open source is great for actually contributing to as well. Not just, it's not just, I don't have to deal with the procurement office, you know?
Okay. No more questions as it seems. Okay.
Okay.
Thank you, Hadi.
Thank you.